The next definition we have is simply core. Core is the material that makes up the interior of the door, and it's really odd in the sense that initially, at least for me and so many customers also, hey, that door's not hollow, is it? Hollow metal door. The door's never hollow. There's always a core of some type, but it's a bit of a confusing misnomer. Hollow metal door, that's what we call them. Steel doors, yep, pretty much, but hollow metal is division 8100, and that's a hollow metal door. They're never hollow. There's always some core inside of there. Let's talk about what those different cores are right now. We'll start with honeycomb. We'll go in terms of maybe what people expect all the way to what people don't expect. And in no particular way are my definitions technically proper or going to be absolutely what you'll want to depend on. However, my definitions are also based on years of experience. Honeycomb is the most common type of core that literally looks like what you would see in a bee's nest, that hexagonal type structure. And it's paper is really what it is. It's thick paper, but it's actually paper. Honeycomb is used because of economy. You want the cheapest door possible. The cheapest door possible historically was honeycomb. It may not be the case anymore in the sense that the factory, whoever you're buying it from, may not want to do honeycomb, so they'll actually charge you more for it, whereas polystyrene might be the typical common least expensive. But historically, honeycomb is certainly going to be the least expensive, whether it was many years ago by Kawani, if you were getting a walk-in trade situation with customers that would walk into the counter and they would order 3 doors, 3 frames, 3 boxes of hinges, and you know what? They're for bathrooms, so give me 2 push and pull, and then give me 1 keyed lock, because there were 2 bathrooms in the manager's office. Okay, great. I need 2 closers, I need 3 wall stops, I'm done. Guy comes in, why is it so expensive? I mean, that's the first thing. So we're going to stock honeycomb, or we historically stocked honeycomb. It would be a 20 gauge door as well. Client just looking for savings. So a common part number for us back then would have been a VM420, a VMAX door, 4 for 1 3/4, 20 for 20 gauge. It would be cold rolled. It would be a honeycomb core. That's all there is to it. Now, honeycomb is actually not an awful type of core to use. It's not. It actually has an R value that's not impossibly inconsequential. There's actually, the structure of honeycomb does allow a small amount of R value. The structure of honeycomb makes it very crush resistant. So the problem with honeycomb, however, is it doesn't do really well when it gets wet. So when the door opens to the outside, the top cap on the door, rain hits the side of the building, it trickles down the face of the masonry, gets to the lintel, lips back over, down the face of the frame, down into the rabbet area, and then starts to drip right into the top of the door. The top cap is not sealed, it's not waterproof, so that water gets down there. Over time, the water collects at the bottom of the door, and that's why you see the bottom of doors and frames that will rust, because that's where all the water is actually meeting up for the party. So that's where it's pooling and collecting. As it comes down the way, if you've ever encountered a steel door that has to be replaced, you can take your hand on the one corner and grab down here, and you can start to twist it, and you can hear the door crack and crinkle. And what you're hearing is the surface, the inside face of the door, and all the oxidation on it. You're hearing all that rust crack off. So the issue with honeycomb is that when they use that as a core, they have to glue it in. So what they actually do is put it through a set of pinch rollers, and they crush or fold down the face of the honeycomb, inherently destroying its ability to be strong in terms of crush proof. And they're doing that to get surface area that they can get glue applied to. And that glue is only going to stick to an unprimed inner face on the steel door. So that's another bad thing. You've got steel that's rusting instantly after it's manufactured. You got a lot of hollow areas. If you were to peel open one of those doors, you will literally see the oxidation around those areas that the honeycomb had attached itself to the inside face of the steel. Honeycomb's still very used. It's really big at the Seco plant. There are other manufacturers who you just can't get a honeycomb door from them. And in fact, what's really interesting is the world's largest retailer, it's a household name, their specification calls for a 20 gauge honeycomb door on their bathroom doors in their facilities. And I just scratch my head. The world's biggest retailer, with the amount of traffic that goes in and out and just smashing those doors all day long, they must have just realized it's cheaper to replace those doors as needed than it is to have a heavy-duty door. I'm not really sure. But I thought to myself, the world's largest retailer, who knows how many billions of dollars in gross sales a year, and their spec calls for a 20-gauge honeycomb door. You can't get any less expensive than that and still call it a hollow metal door. So that's honeycomb. So the upside is it's inexpensive and it is durable. The downside is that it's going to be the core that is not even close to being completely adhered to the face of the skin. The face of the skin is not primed, it's not protected at all, and you're inherently pinch rolling and crushing the honeycomb, reducing its effectiveness as to the mechanical structure of what it is to do the job. You only want honeycomb if really the cheapest thing is really what is most important, and you couldn't care what the core was. Honeycomb, in that regard, would be the best option for your application. Let's move on to the next core type. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. So the next core to talk about is indeed polystyrene. Polystyrene is a type of foam. I don't know very much about how it's manufactured, but I know that it's a really typical core. According to Seco's catalog, it has thermal characteristics of an R value of 3.23, so not really high on an R value, which translates or converts to a U factor of 0.31. But at the end of the day, it's something there. It also has a not insignificant STC rating of 23. When it comes to STC ratings, that is certainly not considered an STC door at all, but that is what polystyrene comes up to. And let's talk about a little bit of how that's manufactured, I suppose, and what it actually looks like. So let's do that. Okay, so according to the definition of polystyrene, it's called a synthetic polymer made from mononomers of aromatic hydrocarbon styrene. I don't know what any of that really means. Polystyrene can be solid or foamed. General purpose polystyrene is clear, hard, and brittle. It is an inexpensive resin per unit weight. It is a poor barrier to air and water vapor, and has a relatively low melting point. So, general purpose, inexpensive, and not super high performance really much at all. Impact on the environment. Polystyrene has many negative effects on the environment. Slow degradation. Polystyrene can take hundreds of years to decompose, and research suggests it can last in the environment for thousands of years. Not biodegradable. It can leach harmful chemicals into the environment when it decomposes. It's a dangerous air pollutant. Hazardous waste, because it is classified as such, and according to generative AI in Google, it's becoming a major source of hazardous waste. Polystyrene also contributes to global warming. It's a threat to wildlife as a result of all of the above, and does have toxic effects. So not really awesome. Polystyrene is not easily recyclable and can end up in landfills, waste to energy facilities, or the environment. So pretty dreadful in that regard. I know that polyurethane is a major contributor to the negative impact on the environment. And I want to go back to honeycomb. Honeycomb cardboard, which is pretty much what it is in a door, is a sustainable alternative to polystyrene foam. Wow, Honeycomb 1, Polystyrene 0. It's made from 100% recyclable craft paper and is glued together to form hexagonal cells. Honeycomb cardboard is durable, economical, and has high tensile strength. It is used for print boards and displays and in construction to carry heavy loads. Taking a door and crushing it like this is obviously something that you want the door skins to resist, but the fact that it's highly recyclable and does not have that negative impact on the environment. The issue, though, is I don't know if I have any easy data on its profile. Okay, check it out. Honeycomb. This is really great. Sound transmission STC32. So it's 40% higher than polystyrene for STC. It doesn't give any R or U value. I would think that it's extremely low because it's just air that's there. But it does have an STC rating of 32. And I'm pulling this out of the catalog, the Seco catalog. You know, I'll tell you this journey of going through all the SDI definitions has, in most instances, in all instances, has certainly helped me understand the item better because I've been forced to think about it and maybe do some studying off camera. But in this case, looking at the data on honeycomb, I guess we need to rethink honeycomb in the sense of it being something because it's highly recyclable, it is inexpensive, and it has a better STC rating because that's really important everywhere. So if you're doing a retail space, I've done these where they want an STC rated door but don't want to pay an STC rating, I would now be telling the client, don't do polystyrene, do honeycomb. It's a mechanical room, you're not going to be going in and out a lot, and if it was an exterior door that may be more important for STC rating, I might just recommend a closed or a sealed top cap, or I might personally get in there with silicone caulk and seal all of that. So again, score, honeycomb 1, polystyrene 0. Let's move on to polyurethane because that's the next one in my list. Polyurethane is a core that I think of as a real high-end core because it's extremely dense and its R value is really high as well. At least I think it is. I found that I was not exactly on the mark when it came to polyurethane, polystyrene, but yeah, in this instance I'm definitely right about the thermal characteristics. Polyurethane has an R value of 11.01. That's really high-ish for a door. Back in the old days, well, for me, the old days would be the early 90s. Polyurethane was no problem. In fact, it was more common when we distributed Kawani than polystyrene was. So initially, for me in my career, there was the E-Series door, which was their economy grade door. That's going to be a honeycomb door. And then their D-Series door, it was definitely going to be something that you're going to see as a polyurethane, as a possibility. I don't have my old original Kawani binders. I think I got separated from them in 2001 or so, meaning I don't have that price list to see. I think if you ordered a D418, a D-Series door, I think the standard was polyurethane, but I don't recall. Then the VMAX door was introduced, and then you had honeycomb available, and then you had the ability to do a polystyrene on that as well. Anyway, an R factor of 11.01. It has an STC rating of 26, so not as high as honeycomb, but higher than polystyrene. Now, you're going to find that on the Seco Maxim door. You're going to find that in their Storm Pro. You're going to find that in their Imperial door. And the Imperial is really the one you would think of most commonly. So let's see what impact the environment polyurethane has. Again, the same AI sort of answer. Polyurethane, they call it as PU, has several environmental impacts. It's made from fossil fuels like petroleum and natural gas, which are non-renewable resources. The extraction and processing of these resources can negatively impact the environment, including air and water pollution, destruction of ecosystems, greenhouse gas emissions, which contribute to climate change, toxic substances, carbon dioxide emissions, and that's where it was really pulled back in terms of its use, and the people that still offer it, like Seco, you can order it, but it's a lot more expensive. than it was 3 decades ago. Land use. At the end of their life, polyurethane products are mostly incinerated or landfilled, creating an undesirable environmental effect, such as land resource consumption. Washing clothes. Washing clothes made with polyurethane fabrics contributes to microplastic problems in marine environments. Interesting. However, polyurethane is more environmentally friendly than most plastics because it doesn't contain any chemicals that disrupt the metabolism of living things and doesn't change the pH of water and soil. So there you go. That's polyurethane. I've always thought of polyurethane as, you want an insulated door, you can have polystyrene, which gives you a marginal amount, 3.2, or you can have polyurethane that'll give you a much higher R value, 11.1. But what goes along with that is the fact that it has a major footprint on our environment. Let's move over to steel stiffened now and talk about that. There's probably different ways that manufacturers do that, but let's talk about it as a core. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. Okay, let's talk about the next core that I have in mind, and that's steel stiffened. Steel stiffened, as far as I know, is a core that's extremely, it's not unheard of. You're going to bump into it. Someone's going to ask for a steel stiffened door, and I think the logic is that they're far more durable. I think having the structure of steel on the interior of the door is something that makes people feel like it's more robust. And boy, there's a lot more steel. Well, first, as far as I have been told, decades ago, UL testing in 1970, to get a 3-hour, the manufacturer had to build a steel stiffened door. So I believe steel stiffened is somewhat a legacy item in the thinking of, boy, to have a 3-hour door, you need to have a steel stiffened core. Originally in my career, when I started, customers asked, well, it's got to be that one that's got the steel on the inside. It's got to be that, what Kiwani would have called a rib core door. No, you don't need that at all. And then it was always, what do you mean? It's always been that way. And in our industry, a period of time measured in a decade or 2 decades is really not that long of an amount of time for products to evolve, with the exception of access control or stuff that's being very hotly developed. The grade 1 cylindrical lock is not undergoing any revolutionary design improvements in the last few decades, and if anything, it's been de-evolving in terms of quality. But access control, that's just going elliptical. The platforms of high security cylinders, that continues to get evolved, whether it be multi-lock or it be the new Medico 4 as a replacement for its predecessors and whatnot. But in terms of hollow metal doors, really what's happening now is a concern over impact in the environment, along with making the material more suitable to energy savings. So steel stiffened is a core that is on the list. It's going to be a core that's readily available by different manufacturers. And let's talk about the basic design and construction of it. So steel stiffened doors, that's the name that you're going to see it classified. That's how it'll be called in a manufacturer's catalog. Rib core or hat channels is not unusual to have the internal components referred to as. Kiwani called it a rib core door. And those ribs are basically pieces of steel that are welded on the inside of the door sheets, 6-inch on center. And they're basically hat channel. So it is shaped like a hat. So you could put it on. So the flanges of the hat would be welded down to the face sheet. The face sheet up on top, it would have its own hat channel welded to it. The door skins or the pans would be brought together, and those two flats, like the soffits, think of a header. It would be the soffit. They would make contact with each other and sit on each other. And I believe there was probably epoxy or some sort of adhesive that would be applied there as well. And those channels would sit on each other. In between the voids of the 6-inch, they would literally add what looks like steel wool, what's called mineral rock wool, and it's a filler. It's an insulating product, although I can't really tell you how high it is on any R value, but we'll discover what's published. So that would be the material in between. There is at least one manufacturer I know of, Carpen Steel, who we do business with, that if you need a certain particular arrangement, it might be a 3-hour door or it might be a UL. The way that Carpen tested that door originally was a steel stiffened. So I know that I've received responses from them saying, well, this door can't be polystyrene, it has to be steel stiffened because of the requirements of a fire rating. So their legacy test still applies, but they are forced to supply you with a steel stiffened door. So the advantage is, boy, that's a lot of crush resistance. You've got welded steel. The problem is what happens in the voids between the 6-inch on center. Sure, it's more durable, but if you were to take a carton, hit the door on an angle, you'd still dent it. You'd dent it anywhere, really. But it's not as if it's a panacea of a more durable door. The significant downside, and it's something that plagues steel stiffened doors to the point where I'm quite sure that there are manufacturers that no longer weld, but when they take the hat channels and weld it to the steel, there's evidence of that weld that's left over. You may not see it when the door is primed, but you can see that after the door is painted, and there are times when it is seen. The amount of scrutiny that the steel stiffened door would go through in the factory was just crazy. A human being running their hand over it, looking, trying to determine whether or not there was the artifact of welding that had been done, and there pretty much very, very often is, and that's definitely not advantageous when it comes to a steel stiffened door. The other downside of it is you are adding a lot of weight to the door. Now, a heavier door, the better? No, not really. You need a door that performs, but a heavier door is going to wear out your hinges a lot sooner. It's going to wear out the attachment of the frame to the door a lot sooner and things of that nature. So I'm not advocating a lightweight door, but I'm advocating a door that's appropriate for the application, and I'm just not convinced that... Oh, thank you very much. It was unscripted drama. Wednesdays is our day of Rich Buys Coffee. So it is Wednesday at about 8 o'clock. So in terms of it being a heavier door, that's somewhat of a disadvantage. If you're dealing with a 16-gauge steel stiffened door, I'd really be arguing for pivots or continuous hinges, or possibly 5-inch heavyweight, or even 6 by 5 heavyweight hinges, because it is a really massive door. Let's see what I can find in the catalog regarding a steel stiffened door. So according to Seco, it would be their medallion door, and the medallion is a very common door. I just supplied the architect wanted 16-gauge steel stiffened doors on the exterior doors of a country club in the back of house food prep area. 3'6". These doors are going to get slammed all day long, in and out. I can't really say that steel stiffened is a better option for that. It is in Colorado. So if it was me, I'd probably go with a 16-gauge polyurethane door, and I would run that either... I don't love continuous hinges because they don't look really nice, but a full mortise continuous hinge on a 16-gauge polyurethane door would be my go-to for that. 3'6". It's 7.0, and that's where the staff is coming in and out all day long, serving people in and out all day long. And I think that'd be a pretty good option. I'd put an 8x20 push plate on the inside. I'd put a durable but not too large pull plate. You know what I would do is I would very likely add high energy to that opening so that servers going out would be able to just walk up to the door and have it open for them. I probably wouldn't put a sensor on the outside. A mat would be really nice on the inside, like you had in the grocery stores in the 1970s. There's a lot of code to unpack there in terms of making that all code compliant, but I'm just thinking of what would make an agreeable opening. I would probably have a wave switch on the outside with a key switch to open that circuit, making it easier for the staff to move around. Obviously a narrow light, probably a 3x33, just so that you can detect, or even something much smaller, like maybe a 3x18, just to see if there's a body there or not. So anyway, steel stiffened. According to Seco and their medallion door, when it comes to steel stiffened doors, Seco says their standard gauge on vertical steel stiffeners for added strength, they say, is 22 gauge. You can also do that in 20 or 18 gauge. Okay. In between the voids, they say that there's fiberglass insulation for thermal and sound transmission reduction. Awesome. That medallion door is going to be a seamless door. You're not going to have a seam on the outside. That's going to be welded to a certain extent and filled closed. So yeah, you're getting an entire door that the outside skin, the edge, the inside skin, the edge, that's all now in assembly. So that's pretty durable. That medallion door is also going to have a steel end channel filler cap. Obviously, you're going to want that to keep moisture from getting down there as much as retarding it as much as possible. On their medallion door, and this is important to note, if you go with a 16 gauge steel stiffened door, Seiko's tested it to 4 million cycles. Okay, 4 million. So let's say that door is opened, let's say 1,000 times a day, and let's say that that's 6 days a week, and let's say that that's 12 years. Yeah, 12 is perfect. So if you've got a door that's used 1,000 times a day over the period of 12 years, that doesn't hit 4 million cycles. That's one hell of a door. That's one hell of a door. So what's interesting, what I had said earlier about the weight of the door when you add steel stiffened, when you go to a 14 gauge door, that cycle count drops to a quarter. So if you use 16 gauge, they've tested it to 4 million cycles. You go to 14 gauge and that's 1 million cycles. And that's got everything to do with the fact that that door is massively heavy. It's really, really, really heavy. They have a temperature rise door that's steel stiffened as well. We'll talk about temperature rise next. All right. So they don't give an STC rating, at least not what I've bumped into yet. They have a entry that tells us that in their line of medallion doors that are Maxim, their vandal resistant door and frame entry system, they have an STC rating of 38 on that. However, that's only a 14 gauge door, so I don't know what it drops down to if you were to go to 16 gauge. But at the end of the day, if you're dealing with a 14 gauge medallion steel stiffened door, you're dealing with an STC rating of 38. There is no offer of R or U value. It's all steel. It's metal touching metal. I would think that it's so awful that they don't even offer anything for that. Now, the reason I would have suggested the 16 gauge polyurethane is that project in Colorado, one day a week, let's say that it's closed. Let's just say it's closed one day a week. And let's say that for 10 hours a day, there's no one in there. I'm still going to want some thermal properties on my core. I'm still going to want to have it not stone cold, the grip of death cold on the inside of that area. And Colorado doesn't get cold like Chicago gets cold, but it will stay cold for a very long time in the sense of months through the year. So I think there's an argument to be made there. Now what we'll do is we'll move on to other cores. Obviously temperature rise. We'll see if we can dive into any specialty cores regarding ballistics. I'm probably not going to have a lot of data on that, but just we'll mention what I can find. We'll talk about the Storm Pro type of doors, windstorm rated material, how that construction may be particular. And then there's certainly going to be specialty manufacturers who have proprietary cores based on a requirement. So let's move on. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Let's talk about temperature rise. And temperature rise, the way that it's always been explained to me is that it's a proprietary core that has the following phenomena. You have this side of the opening and this side of the opening. There's a door between those two sides. The temperature rise doors are classified by degree. I'm seeing 250 degree, 450 degree in the Seiko catalog. There were always 3. There was one that was much higher than that in terms of degree, 600, let's say. And the way that the core works is, over a period of time, the change or the rate in rise of temperature over a period of time, and I believe it's 30 minutes, and it'll say on the label, actually, of the temperature rise door that whatever the temperature rise core door temperature specification, that's the maximum that it can change. So a 250 degree temperature rise door will retard the increase in temperature from side A to side B compared to a 450 degree door. So after 30 minutes, the temperature difference is only 250 degrees on a 250. On a 450, it's 450 degrees. I don't recall the degree in Fahrenheit of when paper will ignite, but you're going to, see temperature rise doors used in those applications where they're trying to slow down that rise in temperature so that firefighting efforts can be put into play on it. Same with safes. Safes are document safes are temperature rise by nature, and they're meant to not permit the change in temperature X degree in a Y amount of time. I think it's 30 minutes. So temperature rise rated fire door. So in the Seco catalog, there is 250 degree and 450 degree. I'm first looking at the 450 degree. Designed for building code requirements for temperature rise rated fire doors to 450 degrees. That 450 degree core has an STC rating of 41. Pretty high. I wouldn't be surprised if doors that were STC doors from Seco and others would be using a core that would be, used in STC ratings and temperature rise ratings. If it does both jobs, they're probably using it in both scenarios. They call the 450 degree, they will do that in their medallion door. They get to a Fuego door, that 250 degree temperature rise door. Yeah, so what's interesting, in the 250 degree version, they classify it as 450 degree. They state, designed for building code requirements for temperature rise rated doors to 450 degrees. Okay, Fahrenheit. You get to 250 degree, the language changes. It says 250 degree Fahrenheit, maximum temperature rise at the end of the first 30-minute fire test. So 250 degree maximum temperature rise at the end of the first 30 minutes of fire test. Okay, so that's, the way I read that is, on the 450 maximum, you've got 450 degree maximum differential. On the 250 Fuego, you're going to get, in 30 minutes, 250 degrees, but then after that, it'll continue to rise. So I would think that the 450 is probably going to get to 450 and stay there. Who knows how long it'll take? It would depend on the environmental conditions. But really interesting that if you want to cap that in 30 minutes to 250, you're able to do that. Let's see what else they say about temperature rise. Temperature rise rated doors allow people to pass by the door safely when fire is on the other side. When an opening is required to retard the transmission of heat from one area to an adjacent area, a temperature rise rated door is required. These doors are typically required in locations such as stairwell access doors, electrical control rooms, paint storage, etc. Temperature rise designations indicate the maximum rise in temperature above ambient on the non-fire side of the door during the first 30 minutes of exposure in a standard fire test. Seco manufacturers, and Seco's just my example. I could pull out the Curry's catalog, I could pull out Republic and Mesker, and if we had a time machine, I could pull out Fenestra and Kawani. So Seco also goes on to say, Seco manufactures two types of temperature rise rated fire doors. Medallion, 450 degree Fahrenheit, is a temperature rise rated door which allows the unexposed side of the door to reach a maximum of 450 degree during the first 30 minutes of testing. So there you go. The language wasn't the same in both, but now they're saying at the 30-minute mark, the maximum on the exposed side is going to be 450 or 250. Fuego is a 250 degree temperature rise rated door which will allow the unexposed side of the door to reach a maximum of 250 degree during the first 30 minutes of testing. Medallion 450 temperature rise door maximum rating is 90 minutes, so you can't get a 3-hour door on that. And they say that a couple of times. What I'd like to do is open up the Seco tech manual, and I'll do that quickly just to see if I can come up with anything. So when I look in the technical manual, I do see a 450 degree medallion door and the Fuego 250 degree door. The STC rating of the medallion 450 is 40 and does not have any R value associated with it whatsoever. The Fuego 250 degree is a 33 on the STC scale, and again, no R value, meaning not applicable. There is no R value on that at all. What I don't know is what that core actually looks like. And there is a Fuego data sheet. There is not one that I found easily, but let's switch to the screen view and let's take a closer look at what that core is represented as. Okay, so in the manufacturer's website, secodoor.com, there's only one 250, but let's look at the 450 first. Yeah, so 450, it's vertically steel stiffened center seam. So clearly what they're doing here is it's a steel stiffened door. You can see when I used the term hat channel before, that's where that's coming from. Inorganic thermal barrier applied to stiffeners right between there. Okay, so they're going to break the transmission of heat to within the extent that that can do it. Elevation types. Now, what I should have mentioned earlier about steel stiffened, boy oh boy, let me tell you this. You don't want to have a customer call and say, yep, I need to put windows in 5 doors. Can you do it? Sure, we can do it. Bring the doors down. We'll cut them. And then you find out that they're steel stiffened. Just let your head wrap around that for a minute. Trying to cut with a jigsaw. It doesn't work. So the 450 medallion is steel stiffened. They, other than inorganic thermal barrier applied to stiffeners, I don't know what that means, like what it actually is. We know this is steel according to its 22 gauge, 6-inch on center, 8-pound density rock wool between the stiffeners here and here, or here and here. So let's look at the Fuego. 250 degree maximum temp, positive pressure. Interesting. So the 250 apparently can go to 3 hour. 250 degree maximum temp rise at the end of the first 30 minutes. Okay, great. So you see something here. Something. We scroll down, you see more of the same stuff. And this is really what it is. Solid mineral fiber core bonded to both face sheets. We don't know what that is. They don't necessarily tell us exactly what the core is. The core is a one-piece UL-listed solid mineral fiber slab that is securely bonded to both face sheets under pressure with waterproof contact adhesive. So that gives us a generic English description, words in English. We can't hold it, we can't show it. So we're going to use the word proprietary. It's some proprietary means by which they accomplish it, and I think that's really good enough to show that it's some sort of dense slab of mineral rock wool that looks like steel wool that's in a billet sort of form. It'd be nice to see. If you've ever toured a factory, a hollow metal factory, you could probably ask the tour to show you what that looks like. And there you go. Okay, let's move on to the next core. I think I'll dive into ballistics next. What'll end up being the final core that we discuss is bullet resistant or ballistic core type doors, and whether it be ballistic rated or vandal resistant or storm pro, we hit a wall in the sense of having available to us published documentation that says this is exactly what the core is made of. It's this much of this and this much of this. Proprietary is the word that we bump into for those sorts of items. So we'll walk down that path a little bit, and then at that point I'm not expert enough on the manufacturing process of those items to be able to lend any additional information. I think in order to really know a lot more, you probably would need to be purchasing that product line from a manufacturer who supplies it, whether it be Seco or a smaller outfit that might be more boutique or family run, the small independent quick ship custom, highly custom outfits that might do it, and I'll show you a couple. So let's switch to the screen view. So when we dive into what Seco has, we're looking for their armor shield. Let's do a right mouse button over that, and let's also do the same on attack resistant. So let's take a look at armor shield. Seco armor shield bullet resistant door and frame assemblies supplied with the appropriate listed hardware will meet most job requirements for security and protection. So first of all, they're selling you an assembly. It's been tested with the means of latching, the means of hanging the door, and whatever else is necessary for the compliance. Armor shield assemblies offer 8 levels of bullet resistant protection. This is cost efficient, readily available solution, protects against assault and vandalism at vulnerable door openings such as isolated utility buildings, cashier islands, currency exchanges, or box offices. It sure goes on to several more applications than that. Safe rooms and homes. Okay, I supplied the client a hollow metal frame, not from Seco, but from DKS, run by the remnants of people from Amweld, at least 2 of them that I'm aware of. And I sold this client in Texas an expandable frame, and many people make expandable frames. DKS being an importer of material, they're bringing in container loads of hollow metal, and they're probably remanufacturing in California. But I needed something on the shelf, and again, being a importer, I went with DKS because it was on the shelf. So I sold the client an expandable frame. He then literally came back to the frame after he received it and lined it with level 6 ballistic material, or level 4, something midway up the chart, and the walls and everything. So the adjustable frame wasn't because he had an unusual varying wall thickness or something odd in the sense of normal construction. What made it odd was his need to not only accommodate the ballistic material that was in the wall, but the ballistic material he would line on the inside of the frame. And he was putting that all in himself with a proper adhesive or epoxy, and he was building a safe room. There's no doubt. I couldn't fathom the need, thankfully, for a level 4 safe room in my home, but he apparently did. So we do have a SDI video on bullet resistant, and I went into it as best as I could, deeper than this. These are the levels. The important part is, when you look at this, is you get cursory information. You get the fact that it's tested, but you don't get anything about the core, and this video is about the core. If we hop over to the attack resistant, just because we're here, again, doesn't give us much information about the core type at all. Although it does here. On attack resistant, they do list polystyrene, polyurethane, honeycomb with 16 gauge sheets. Yeah, I defy you to kick in a 16 gauge door, especially a seamless door with a grade 1 mortise lock and a deadbolt. That'll be defeated when someone backs into it with a pickup truck. Now, this company DCI, I don't believe I've ever done business with them, but when we search their document, they do have a reference to bullet resistant, and they at least take the effort of showing us something. But there's that word, proprietary. So 1 3/4 door thickness, 14 gauges available. I'm not sure the standards. I don't know that it matters. I'm sure that it matters, but it's the core that's doing the majority of the work. So there has to be a minimum gauge on the outside. Probably 18, probably 16. Obviously 14 is not standard. So G90 available, stainless available, satin mill or mirror. That's nice. Proprietary bullet resistant core. So when you specify level 1 through 8, I would imagine that this core is going to change in the science of how it's built. UL 752, levels 1 through 8. Yeah, it tells you right here, 16 gauge. Sorry, I missed it. So you're probably not going to do an 18 gauge, 16 or 14 only. Levels 1 through 3, really, really interesting. Approximately 9 pounds per square foot. Okay, that's somewhat pedestrian in our business, somewhat. If you do a 4080 16 gauge door, it's going to be pretty heavy. But here's the exciting stuff. Levels 4 through 8, 22 pounds per square foot. So 22 times 21, a 307, a 307 is going to weigh 462 pounds before you attach all the hardware. That's really interesting. I imagine they'll supply this as an assembly, like Seco listed that they do, but that's pretty crazy. 22 pounds per square foot. It'd be nice to see that test. So, some real stuff happening there. I mean, what does a sheet of 21 is 3 times 7, 3070, 21 square feet. So, what is a sheet of, the weight of steel plate can be calculated on length and width, thickness, density. Length, 83.125, 35.75, 0.25. Let's see if that works. Yeah, 210 pounds. Yeah, that to me would make more sense. If you had a piece of 1/4-inch plate that was 21 square feet. So if they're skinning that ballistic material in 16 or 14 gauge steel, that ballistic material must be really dense in order to be those levels that it's rated for. Must be really, really dense. Level 4, 30 caliber, all the way up to whatever this is. I'm not 7.62 millimeter. So it's stopping a lot of energy, and that would probably explain why it's so heavy. When a piece of 1/4-inch plate is 210 pounds, you would think a 1/4-inch piece of steel would stop a large projectile. Anyway, that wraps up the core definition. I think we've properly killed it to death. And let's take a look at where we're going next. Corner clip, see reinforcing gusset. Yeah, let's talk about that. Thank you for watching, and if you've enjoyed this video, please click thumbs up. Please subscribe and maybe even send the video to someone that you know. Thank you.